Good morning, it's 9:24 a.m. Central Daylight Time. This is Francis, your favorite amateur astronomer, bringing you the latest Comet ISON images taken this morning, Saturday, October 26th. This is the blink comparator system running within the Mac software that I use to examine and in the end show you the pictures that I've taken. This morning I was able to take images with two different telescopes. These images here are taken by my go-to telescope for this comet. It appears T4 from itelescope.net, located in the New Mexico skies observatory complex for itelescope.net. What we're looking at is 7 frames. 2, 3, 4, 5, 6, 7. I can report to you this morning that the comet is healthy, very healthy in my opinion, and really showing great promise for its great arrival at the end of this year. Remember that November 28th is its perihelion, which means its close approach to the sun, the closest it will get to the sun. That distance has been estimated at about 680,000 miles. If this comet makes it around the sun at that distance, the sun will surely create a wonderful view of the dust and debris that this comet will expel on its passage by the sun. You can see here, at least in my opinion, that this is a pretty solid piece of comet. You might notice this here, but this back here you'll see is a star. Stars. You always want to look at the stars. Are the stars acting like each other? Is the comet moving toward or away from an object? This is about as close as I like to get. Resolution I have with T4 is good, but you start getting any closer and you're really dealing with pixelation. So those are the first views for you of the comet from this morning. These images were taken starting at 5:30 a.m. I'll stop and we'll look at the Fitz header, and you can get an opportunity to stop the video and see the information that comes with these images. Plus you get a chance to see the T11 telescope image I took. Alright. Here's Comet ISON here, looking through T11, a planewave CDK 17-inch, I believe. Something interesting occurred with this image, because I opened it up and recognized immediately that the comet is not in the center of the image, which means somewhere in my planning when I generated a plan and entered in the coordinates, I must have entered in the coordinates from a half an hour or 15 minutes on the wrong side of when I actually took the picture. So it's important to make sure you pull the right coordinates and put it with the right exposure time. But we still have it. I might have wanted to get a little bit longer tail, but we still have it here, and we'll go in and take a look at it. Again, these are all raw images. First time I've seen them, first time I've worked with them is when we get to see them together in these videos. I'll try to get it as much as I can in. Okay, and this is an auto adjust. This is the actual resolution, and I'm going to darken up the back. Actually, I want to get in a little closer, because our resolution with this camera is much better. You can see everything, the stars in the background. If anything appears up here, center this. Now, important note, someone asked the other day, what's in the tail? Why do we see the tail? What's in the tail? The tail is dust that's being expelled from the comet's surface. A number of varied volatile gases that can be frozen inside a comet. CO2 is the most common. In June, the comet was reported to be expelling 2 million pounds of CO2 dust a day. By now, it must be up to 3 or 4 million pounds of CO2 dust a day, and that's what ends up being the tail. Now, for our electric universe friends, which I am a follower of the electric universe, I speak these words and observe what's happening to correlate the two. In my opinion, there's no reason why there can't be dust within an electric universe. It's still about the nucleus and its electrical charge, one way or the other. I'm going to go ahead and kind of smudge it out, make it a smudge, see if there's anything particular that there really isn't. I'll auto adjust it, it'll go right back to a nice fine nucleus. 8:24, 8 minutes 24 seconds. And all this is evenly dispersed dust. Get you some. Okay, let's have a different view. This was my intention. And again, this is from T11. Let's look at the image info. Object. Telescope, Francis Walsh. Use the luminance filter. The site, longitude, latitude. The time and day. And the coordinates. So I could do a plate solve the image and see where I went wrong. I went wrong somewhere in between here in the center of the picture and here. But okay. changing the filter, the visual for this image to the rainbow mode. Let me get a different look at it. Star, dust, okay. These images, while we're looking at them, are the latest images from this morning, 5:30 a.m. This image here was actually taken at about 4:55. These images, I had to sneak in to take these, and somewhere in my getting of the coordinates, I made a 5-minute mistake. I think that's really where it comes down to. This is what the comet looked like. The image looks like we had moon. All my images were a little bit moon affected by the moon, but still definitely workable. The moon doesn't stop you from taking these images of space, and in fact, you can take images with the moon out and get a discount while you're taking them. Trying to get as much done in the 15 minutes that I can. Okay, well, what we have are 1, 2, 3, 4, 5, 6, 7, and images taken with T4, and one image here taken by T11. Well, that's about it. The latest and greatest. Say hello to all you new people who've come looking for Comet ISON pictures. You've come to the right place, if I don't say so myself. To all my friends, we have long lists of them. Hey John, hey Jess, hey Jack, hey Chuck, hey Pie, hey Suspicious Observers, hey Envy, hey Kornos. You know, the list is in the thousands. So this is about it. Comet ISON. It's good, healthy, and ready to go. We'll see you later.